All right.
Yeah.
You had 10 problems for homework, and there's 5 on the board.
Hey, that's really
Yeah, but they all had pictures. Okay, so let's start with number 2. And well, only 3 of them are even. Not bad, I suppose. So we have a graph that looks like this. Ooh. So the top one is y equal 1. You know what? Maybe I might give you the graphs for most of the problems, but I'm not gonna label them. You at least gotta figure out which one is which. You guys can do that, right?
Wait, like you're gonna list the two equations?
Yeah, I have to give you the equations, right?
Okay, yeah, I thought you meant like we have to find our own equation. I was like, oh my god, no. Oh, it looks like that's.
Hey, I just thought of an idea.
Oh my god,
Oh my
no,
God.
no, I'm so sorry.
Wait, wait, wait. That wouldn't work out.
No,
too
we're
well.
AD. Come on.
Okay, so should I do vertical rectangles or horizontal or in this one, or it doesn't matter? Definitely vertical,
Sorry.
because, well, the biggest hint is because the equations are given as y equals, right? So the length of the rectangle is top minus bottom, so 1/2 secant squared x minus the bottom, -4 sine squared x, multiplied by the width dx, and then you add up all of these rectangles from or should I go 0 to pi over 3 and times it by 2 since you have symmetry? What do you mean, no, yes, because it's easier to plug in 0 than -pi over 3. You guys already have problems with trig functions as it is. Now, do you need me to finish this? Because you want to see the answer.
Yep.
Okay, so minus a negative times a negative equals a positive. And then what's the only way to integrate sine squared x?
1/2 minus 1/2 cosine.
Okay.
Oh, 4x.
No, 2x, and then when you distribute the 4, you're gonna have 2 minus 2 cosine 2x. Correct? Now we can do it easy. 2, the antiderivative of this is 1/2 tangent x, plus the antiderivative of 2 is 2x, and the antiderivative of this, is it just negative sine 2x?
No, space for the one.
No, the answer is yes, because it didn't leave a space.
No, because there's a 2 in front of it.
Yeah, because there's a 2, so when you put the 1/2, they cancel out. See, I fooled you. From 0 to pi over 3. Plug in the top number. Tangent pi over 3. I can do it, can you? Tangent pi over 3. Okay, root 3 times 1/2 plus 2 pi over 3 minus sine of 2 pi over 3. Root 3 over 2 minus plug in the bottom number. Don't assume that when you plug in the bottom number you're going to get 0. In fact, we just had a BC test. A lot of people have lost a lot of points. In this particular problem, if you plug in 0, yes, you get 0. But what if you have like cosine or e to the x? Then it's not going to be 0. So watch out for that. And look how nice this is. This cancels that. Come on. 4 pi over 3 is the answer.
I have a question.
Mhm.
For the next problem, or like number 4, which is not up there, can you just explain how you know the limits?
Go on,
Because it was
let
like weird.
me look at the graph.
Yeah.
0 to 1.
But didn't it go before 0 to?
Okay, well, let's do number 4 then.
Oh, I have the answer. But then,
Okay, let's set up the problem then. So, so this one on the right is x equals 12y squared minus 12y cubed. And the one on the left is x equals 2y squared minus 2y. So how come this one we want to make horizontal rectangle? Yeah, because the equations are given as x equals, right? That's a huge hint. So the length of the rectangle is right minus left multiplied by the infinitesimal width. Add them up from 0 to 1.
oh. Oh.
Because remember,
Yeah.
when you're integrating in terms of y, you gotta go from the y coordinate here to the y coordinate there, yeah? You gotta look at the y coordinate.
Kind of brain fart.
Okay, number 7. Oh, this is a calculator problem. This is a calculator problem.
How do you do it on the calculator?
Well, okay, you know what? Is that rain?
Yes.
Okay, so I've got problem 7 and 8. I don't have to do both of them. Why don't I do 8 so then, you know what I mean?
Yes.
Okay. Now, what happens, now how do you know, don't worry, on the quiz I'm going to tell you, you need to use a graphic calculator. So, if you were to graph this on your calculator, you would get cosine looks like this, yeah? And then y equal x minus x squared 2. Wait, let me just, I'm trying to draw it accurately. 3.75 root 2. What did I just say?
3.75 root 2.
Okay, so I think the graph looks like this. Am I right?
Yeah.
Am I right?
Yeah.
Okay. So we have to find the area of this region. So you draw in the rectangle. The length of the rectangle is top minus bottom. Which is the one in the top? Okay, so top minus bottom multiplied by the width, and I'm going to add it up from. Well, obviously from here to here.
So like.
But how do you know what the x coordinate of these points of intersection are?
Calculate.
Yeah, you gotta use your calculator, you cannot do it by hand. So what you do is you graph both of these on your calculator, g-solve intersection, and then you get the x coordinate of that point, which is, what did you say?
1.153.
Okay, when you write it on your paper, 1.153, but you guys know that when you use it in another computation, you gotta use all the decimal places. So, you know when your calculator computes this, you either gotta write down all the decimal places or store it. You guys know how to store it?
Is it like K or
Yeah, you
something?
can
You store it as?
You know, what game are you playing?
I just got a message.
That's a game? That's a game? Who can get the best message?
What?
'Cause I don't know how.
So just like do the g-solve integral instead.
They have a g-solve integral?
I did. Yeah, there is, but I didn't know how to use it.
So you g-solve,
You g-solve, it's like under integral you put intersect and you choose the 2 points that intersect.
Whoa.
It's like,
and then it computes the area?
Ooh, I want to do that now.
Do you have this?
I never heard of that before.
Show us.
No! I want you to do this.
Oh.
dang it.
Okay, anyway,
Yeah, it does work.
instead of going from negative 1.153 to positive, what about just go 0 to that and times it by 2 because you got symmetry, right? Your calculator doesn't care. If you're going to do it on the calculator doesn't care. Anyway, when you punch this in, you have to use all the decimal places. So you can either manually punch it in by hand, or what's another way?
Store.
Store it. So when you calculate this point of intersection, you're going to get, your calculator gives you the coordinates, yeah? This number, with all its decimal places, is now stored in x.
Oh, so you just put X? Or,
Yeah, so you could just put x up there.
and then another zero?
Or, but see, the problem with that is, if you do another computation, then x is going to wipe out the previous one. So what I usually do is, I go to run matrix mode, I type in x, and then this number with all its decimal places comes out, and then you store it into something like a. You guys know this button means store, yeah? And then you can just put a over here. Or if you don't like that method, write down all the decimal places and then just make sure you use them all there. Because if you are off in the third decimal place on the AP exam, a whole point comes off. That's 11%. 1 out of 9 points is a little more, 11.1 repeating percent. That's how much you're gonna lose. So if you have like, what's the final answer? You got the final answer?
4.332.
Is that correct?
Yeah.
You guys used all the decimal places? Okay, if you didn't, then you might get it correct, right? But you don't know if you're gonna get a rounding error or not, so you need to use all the decimal places. But that's how you do problem 7 and 8, you gotta use your calculator.
You can also do that like this.
No, you know why? Because if you do horizontal rectangles, look, what is right minus left? It's the same graph, and then you have a problem. And not only that, how do you, if you go right minus left, that means you have to take these equations and solve for it. What am I talking about? Okay, here are the equations. You're gonna have to take these equations and solve for x, you're gonna make it into the form x equals. I mean, you can, like, what would this one be? 2x equals cosine inverse y. X equals cosine inverse y over 2. I mean, why though? You know what I mean? Anyway, but you can't, because look, right minus left is the same curve. You can't do it. All right, 9 and 10, and we're done. Number 9, dummy. Number 9. Okay, so you got a graph like this. Zhink. Line and line. So this line is y equal x, y equal 1, y equal x squared over 4. Find the area of this region. Now there's two ways you can do it. You can do vertical rectangles or horizontal. This one you can do both. Which one is easier?
Vertical.
No.
No?
Horizontal, you know why? Because if you do vertical rectangles, you gotta make two integrals. You gotta go, so, because look, if you make the rectangle top minus bottom, right? But what happens when you hit here? See how the top minus bottom is now a different function? It changes. So if you're gonna do vertical rectangle, you're gonna have to make two integrals.
Oh, yeah.
One from here to here, where is here?
1.
So 1 from 0 to 1, so top minus bottom dx plus, and then how do you figure out this area here? The integral top minus bottom. You guys understand why you gotta make separate integrals?
Yeah.
Because the top minus bottom changes. And then from 1 to 2. Yeah.
Is it okay if we took the y equals x graph and y equals 1 graph and we found the area of that under the curve?
Like this, find this area.
Yeah, and then we subtracted the area of y equals x,
Of the
x squared
trapezoid.
over 4. Yeah, so we just found the area of the trapezoid, then subtracted the
Oh,
other
find the area of this trapezoid and then subtract this one.
Yeah.
Yeah, that works too.
Okay.
Anything that's mathematical.
I didn't get it.
Okay, but look, why not just make a horizontal rectangle? Because right minus left, look, throughout the whole thing, the right minus left just stays the same, yeah? It doesn't change, so you can just do one integral.
What do you do with the 1?
Oh wait, never mind.
Yeah, so it's just gonna go 0 to 1 then, yeah? So, what you need to do is solve for x. How do you solve for x in this one? That's the square root of 4y. And how do you solve for x in the x equals y. So, the length of this rectangle is right minus left. So, root 4y minus y multiplied by the width, add up all the rectangles from 0 to 1. So you can do two integrals, you can do one integral, you can do the Bailey method. That works too. You guys don't need the answer yet. These integrals are easy to compute. Not like you have trig or anything like that. Or inverse trig. You don't even have to do integration by parts or anything.
Wait, what is the antiderivative of square root of 4y?
Well, there's two things you can do. You can go, okay,
it's y
that's
squared.
like 4y to the half, right? So can I just make the power 1 bigger here? Make the power 1 bigger and put the reciprocal in the front? No, because the derivative of the box is 4, so you need a 1/4 to cancel that out. Or, the other way is to split it up. Isn't this the same thing as just 2y to the half?
Oh, yeah.
Because the square root of 4 is 2, yeah? The 4 comes out of the radical as a 2. And then now it's easier. What do? Make the power 1 bigger, put the reciprocal in the front. Either way. Probably that way is most people would, is my guess. And then finally, number 10. you have y equal x squared, and then x plus y equal 2. Find the area of this region. So there's two things you can do. Can you see that if you make vertical rectangles, you're gonna have to do two integrals?
Yeah.
Because right there, the top minus bottom changes, yeah? So how do you find this integral here? Top minus bottom. Of course, the bottom is y equals 0, right? So x squared minus 0 multiplied by the width, add up all the rectangles from 0 to 1. And then this one, you need to solve for y. So y equals 2 minus x. So top minus bottom, the bottom is 0, of course. So 2 minus x minus 0 multiplied by the width, add it all up from 1 to 2. Now some of you are going, Mr. Park, why do you even make an integral for that? That's just a triangle. Can't they just go 1/2 base times height and get 1/2?
Yeah.
Yeah, you can. Because it's a triangle. Why not? I'm just trying to show you how you set it up. Or you could have just done one integral if you do it with respect to y. Because look, if you draw the rectangle that way, the right minus left doesn't change throughout the integral, right? But then you gotta solve for x. So x equals root y, and x equals 2 minus y. So what is the length of this rectangle? Right minus left. Multiplied by the width, add up all these rectangles from 0 to, what's the y coordinate of there? 1. So yeah, again, you got several ways of doing this problem. And you guys want to know what the answer is?
Yes.
Yeah, I'll do it in my head. 5, 6. Yeah, I still got it.
5, 6?
Yes.
Yeah, if you, for everything, I mean, the total area is 5, 6. I kind of cheated. I used the Archimedes thing. Remember the 2/3 base times height?
Oh. Doesn't work on the.
That's not really cheating. All right, so the lesson to be learned: if the top minus bottom changes in the integral, you got to do a separate integral for it. Okay, you know what? Let's just do one of these. I already did one from the homework yesterday. Let's do another one. Let's pick one that's difficult that you're gonna ask anyway.
Wait, you don't have a new lesson?
No, the lesson is same thing, except you draw the graph. Okay, did I assign number 42?
No.
Really?
No.
I usually assign that every year. Are you sure?
Yes.
Oh man, maybe.
Anything from 11 to 39. That's not 32.
Okay, then I don't think you guys need any help. These are just lines and parabolas and simple trig functions.
Can we do the trig function one?
Okay, did I assign number 29?
Yes, you did.
Now you guys can grab that, right?
Yeah.
Okay, what about, did I assign 34?
Yeah.
Okay, let's do that one. Since it's even. X equals 3 sine y root cosine y. Mr. Park, I don't know what that looks like. X equals 0, and y has to be between 0 and pi over 2. Okay, now you must have a graph now.
This is weird.
Okay, and like I told you before, if you don't know what a graph looks like, plot the endpoints and one point in between and just connect the dots. Okay, now look, it says y goes from 0 to pi over 2. Okay, so what happens when I plug in 0 for y into this? Plug in 0 for y, look.
0.
You get 0. Plug in pi over 2 for y.
0.
0. And then plug in a point in between, like pi over 4. What happens if I plug in pi over 4? And you don't have to give me the exact number, just tell me if it's positive or negative. So x is positive, so it's going to be like this, you just connect the dots. Good enough. The graph looks something like that. And then x equals 0 is this vertical line here. So this is the area in question. We want to find the area of that hump right there. I'm not going to do the whole integral, I'm just going to set it up for you now. So, make the rectangle. What's the length of the rectangle? How come I drew the rectangle horizontally? Because look, they gave the equation as x equals, that's the biggest hint.
3.
Anyway, what happens if you try a vertical rectangle? Top minus bottom will be the same graph. No can. Okay, anyway, so right minus left. So right, this is the right one. Minus left is 0, right? Times the width. Add it up from 0 to pi over 2. Now, I will leave the computation to you. What technique would you use here? U substitution.
Jeez.
Don't worry, the integration by parts 1 will come on the practice test.
Whoa.
Why do you think we learned all those things so that we don't use it?
Yes.
Who said that? Okay, so after today, there's only one more thing left in this chapter, you know, because 8.3 is a whole chapter by itself we're going to do after. All right, let's do a couple AMC problems and we're done. What do you mean, oh no, this thing counts as a quiz next week.